If I create a cube based on like the seed level of my game, I'm going to zero everything out. I'll zoom in, I'll back up a little bit, and I'll hold down the command key and lift this up. This object is 1 meter off the ground, and its center is 1 meter off of the center of space, which means that its center would be in the center of the ground plane. Okay, it's not really important that we're so tuned into that we know where the center of the pivot point is. But when I make an empty game object that's going to hold the player, it's going to be way easier if the empty game object, which has no geometry, lines up with the top of the ground plane. Okay, so I'm going to make some real simple decisions. I'm going to delete that cube. We can always make this empty game object after the fact, but I'm going to suggest that we make it now. I'm going to call it player, and I'm going to move it up 1 meter. Okay, now I might be a meter too high, but I'm going to find out because I don't really have a reference in this game object. But I'll double click on it. That'll zoom it into view, or frame it in view. I'll just get a little bit closer here. The next thing I'm going to do is I'm going to make the body of the player. I got a couple of options here. I'm just going to make this out in the world space. In fact, I'll make it in a really strange position. I'll make a cube, and I'm naming this as I go. I'm going to call it body. And I'm going to scale it in the direction of Z by 2 so that we have kind of a forward-backward direction. So we know what its forward-facing axis is. Okay? And I'm going to drag and drop this into my player object. Now this is in a really weird space. Okay? But once I put it in the player object, its coordinates might change a little bit, and I want to make sure these are zeroed out completely. Okay, and if everything works right, I should have a player character that's sitting on the ground, has a forward-facing Z direction. So I'll select the player, and I can see that its Z is pointing in the direction of the rest of the world space. Okay, this Z direction is not an arbitrary thing. This is our forward direction, and some of our logic and our code is going to reference the forward direction or a look at direction, and so we need to be aware that Z is not arbitrary. The positive Z, the direction that the blue arrow is pointing in, becomes very important in this project. So the next thing I'll do really quickly is create a sphere. This is going to represent the turret, so I'm going to right click this time on the player object, 3D, and create a sphere. Now what that does, by right clicking on the object, it'll create, our contents will get created in the center of it, or at least as a child of it, and then we can zero it out if we need to. And I'll just pull that up a little bit. Now I'm going to decide that the forward-facing direction, I'm going to offset this sphere like kind of an old school tank, and I'm not going to snap this towards the front of the game object. You can move it towards the back if you want, but I've made a mental note that my sphere is towards the front of my game object, so I understand what the orientation of it is. Okay. This sphere I'm going to call turret, and I recommend that you do the same thing so that when we reference the game objects here and start assigning our logic, we're all talking about the same thing. Now I'm going to create one more object, which is my cylinder object. My cylinder ultimately is going to be a child of the turret, but I want to scale it, and so I want to make sure that it's not inside. I want to make sure it's kind of in the root of the player object or in the root of the game space. It doesn't really matter. I'll create a 3D object, create a cylinder, and I'm just very quickly going to scale this, maybe 0.2 along the X and the Z. So I kind of get this barrel looking thing. Okay, I'm going to rotate this either in, I should rotate it in X would be the best way to do this, although technically it doesn't really matter. I'm going to go find my X and I'm going to rotate it 90 degrees. Okay, now if I take this barrel, and I'll name it barrel, and I drag and drop it into the turret, I can zero out its position, and that will line it up with the parent object. Okay, so you can see how parent objects, you can use that for alignment, and I'm just going to drag this out. And I'll drag this up. And this is purely kind of a visual thing, right? So now I have, you know, a basic object that kind of represents a tank. Okay, I'll select the turret. Okay. I'm going to lift the turret up a little bit. I'll move it back a little bit. There's my tank. I'm going to save what I'm working on. So I'm going to control this with physics-based movements. We could control this a number of ways, but I want to use physics because I want to be able to get knocked around by some of the environment stuff, and then I also want to be able to bump into walls and other objects and have them react. And so the best solution in that case is to have a rigid body on this. Now I have an empty game object, which is the player, and then I have contents of my player have colliders, so things could get pretty weird pretty fast. The parent object, I'm gonna choose component, physics, rigid body, okay? Now, if I hit the play button and I go back to the scene, I wouldn't be surprised if, when I go back to the scene, I wouldn't be surprised if, you know, this game object itself, you know, fell to the ground, or if it, you know, fell apart, because it's using the individual colliders now of the children, which can be an okay thing. We'll continue to utilize that if we can get away with it. Okay, and right now I think it's okay. So I have a player object with a rigid body, and I'm utilizing the colliders from the children. So the next thing I'm gonna do is I'm gonna set up basic control. I'm going to add a state machine, and I'm going to look at the camera really quickly because I hadn't considered the camera just yet. Ultimately, I'm going to snap a little script on this, but I'm just changing the view so that I can test. So I can test this. So I really just kind of changed this to more of an over-the-shoulder kind of view, right? In fact, I'll want to go up a little bit higher. It'll make life a little bit easier. And then ultimately, I'll just throw some kind of controller on here. So I'm going to select the player, add a state machine, and this FSM, I want to start naming my state machines, so we have different states that do different things. And I'm going to call this player movement or player move, and then I'll go back to the state. This is going to be a one-state state machine. Everything that's going to happen is going to happen in this state. And so I'm going to call this idle for now, but I might rename it to call it something else. And what I'm going to do is jump into the action browser, and I'm going to find get access vector. So this is an input. If I go into inputs, I can get any key, I can get access. I want to get an access vector. And I'll double click and we can take a look at what this action is doing. Get access vector is capturing user input from the horizontal and vertical axes as Unity has defined them. So where in the past we've often looked at keys, absolute keys, now we're looking at buttons, joysticks, and axes. And so what this means is that Unity has defined a horizontal axis as something that can be mapped to a joystick. It's something that can be changed by the user. So if you go to preferences and say, okay, I don't want my strafe keys to be A and D, I want them to be O and P, I could change those keys. The keys in the game aren't changing, but they're mapping back to what the horizontal axis or whatever the input is. These are custom. We can make these. We can make our own. We'll take a look at the input menu, but Unity has defined horizontal and vertical, and those are mapped to a couple of different things. The AWSD keys, the arrow keys, okay, vertical being W and S, up arrow, down arrow, and also the D-pad to controllers, the left joystick to controllers. There's a lot of things that by default are mapped to horizontal and vertical out of the box. Okay, so we're just kind of taking advantage of that. We're going to use AWSD for now, and then we're actually going to split these out in a minute. So horizontal and vertical, This references the AWSD keys. And before I even wire this to anything, I'm going to store the input that's captured from this action. So let me debug this. And I'm going to create a new variable. This is a vector3 variable. And I'm going to call this player movement. And I'm going to hit play just to debug the user inputs here. Okay, so right now I'm playing, and you can see that my vectors are 0, 0, 0. Whenever you see three vectors pop up, or a vector 3 pop up like this with three floating point numbers, it's x, y, and z. Okay, those are the axes. Now we're capturing input from horizontal axis and vertical axis, and what that means is that our horizontal we know is mapped to left-right keys. So if I hold down the A key, you can see that that first value goes to -1. If I hold down the D key, it goes to +1. Okay, so what that is saying is that our horizontal input is either over here on -1 or over here on +1. Okay, and we have it mapped to keys. It's based on this multiplier here. So right now our value operates from -1 to +1. Okay, x, y, and z. So if I hold down the A key, I'm influencing x right now. Our horizontal and vertical input is mapped to a plane, x and z, which is our ground plane. So when we hold down the left key, x, our horizontal input is x, and our vertical input becomes z. Okay, we can change this if we want to, but this is perfect for our game setup. We could say, oh, I want the up and down key to be x, y, so I'm moving left, right, up and down. Okay, but for this game, this is exactly what we want. Okay, so I'm going to bump up the multiplier here. Actually, I'll leave it. No, I'm going to bump it up. I'm going to cut right to the chase. I'm going to toggle the play button so I can make this change and it'll stick, and I'll type in 10. Okay, and I'll hit the play button again. And now, when I mash the keys around, if I go left and right, you can see that the scale that I'm operating on is -10 to +10. And up, down, you can see that it's skipping that middle axis because we have x and z. X and z, x, y, z. Okay, mapped to that plane. This is a continuous action. It's getting the user input as it gets it, and we can translate that directly to some kind of motion. So what I'm going to do is go down into the physics category, and I'm just going to add force. Double click, and in this get axis vector, we are capturing the user input in this player movement. That's how we were seeing it. We created a variable called player movement. So what I'm going to do is I'm going to go down to add force, and I'm adding force to the owner, the player object, and I'm going to add force based on a vector, player movement. So whatever I capture, I'm going to add to the player. I want to make sure I do that every frame. There's going to be some weird stuff going on here in a moment, and we'll squash some bugs. But I'll hit the play button and we'll see what we end up with. So if I hold down the left key, this works perfect, right? I'll try to stand this thing back up, trying to rock it back and forth. I can't get it to tip. Let me toggle the play button. I'll push forward. Yeah, it's barely moving. Okay, so what I'm going to do is I'm going to come in here and I'm going to bump up the multiplier by 50, just see what happens. It's going to be crazy. Okay, it moves forward. Okay. A little too much. Let's go left and see what happens. Okay, so we're just adding a lateral force on this thing, right? Not what we want to do. So the first thing is we probably want to keep this thing from rolling, and so Alex mentioned the locking the rigid body, so we can do that really quickly. I foresee a situation where we want to be able to rotate from the top down. But we don't really need to, and we might even want to pitch up and down, but we don't want to roll the way we just did, which would be Z rotation for sure. And X, yes. We might want to be able to tip this thing up, like go over a bump or something, and so we'll tinker with that, but we definitely want to freeze the Z rotation. Position we'll just leave wide open. So now, if I hit the left and right, it's not the controls that I want, but at least I got it, kind of sliding around. Okay, and I can move forward. Okay, way too powerful, but we have some ways of taking care of that. So we can dial in. Right now, this is like all over the place. And part of the reason that it takes so much force to get this thing to move is because we have a mass. So we could take down that mass, but then we're still, flying through the air. But if I bump up the drag a little bit, I'll bump it up to say 1 or 2. I'll try 2. The drag is how quickly an object comes to rest or how much force it takes. But now you can see that when I release the mouse or release the W key, it kind of coasts to a stop. So the higher I bump this drag, the quicker it's going to come to rest. Okay, linear drag has to do with forward motion. Angular drag has to do with any kind of torque or rotation. So right now it's getting a little snappier. Okay, so I can increase the force and increase the drag, and the higher those two get, kind of the snappier things get. Okay? So that's get access vector and add force. So let's give that a shot. Even if we just have a cube with a rigid body on it, let's give that a shot.